Today we are going to discuss the topic about MMF method or Ampere Tan method. This method determining the regulation of an alternator is called Ampere Tan method or Roget MMF method. The method based on the result of open circuit test and short circuit test on the alternator. For any synchronous generator, that is alternator, it requires MMF which product of field current and tan of field binding for two separate purposes. It must have an MMF necessary to induce the rated terminal voltage on open circuit. It must have MMF equal and opposite to that of armature reaction MMF. This method of determining the regulation of an alternator is called Ampere-Tan method or Rocket MMF method. The method based on result of open circuit test and short circuit test on alternators. For any synchronous generator, that is alternator requires MMF which product of field current or field binding to separate purpose. One is it must have MMF necessary to induce the rated terminal voltage on the open circuit. It must have an MMF on equal opposite of the armature reaction MMF. This method converse of EMF method. In this method, effect of binding impedance and armature reaction are equivalent to Ampere tan. Hence, this method is called MMF method. The required data for calculation of regulation are obtained from the open and short circuit test of the alternator. IF1 is determined to give rated voltage V, no load neglecting armature resistance drop. Fixed field current IF2 is determined. 2. Causes short circuit current is equal to full load current on short circuit current. Power factor on short circuit is almost zero. Lagging field ampere tan usually used unitide overcome armature reaction. Now let alternator supply full load current at a power factor of cos pi. This is the MMF method. There are two curves. One is short circuit current test and open circuit test curve. This one is a open circuit curve and this one is a short circuit current. Zero power factor method is a PF method or Portier method. This method also called Portier method. In the operation of any alternator, voltage drop occurs in armature resistance drop IRA. Armature leakage resistance drop IXL, mainly due to EMF quantity. Armature reaction is Q's on basically MMF quantity. In the synchronous impedance method, quantities are treated as EMF quantity. In the MMF method, all the quantities are treated as MMF quantity. The ZPF method based on separation of armature leakage reactance XL and armature reaction effect. This armature leakage reactance XL is called Portier reactance. To determine armature leakage reactance EMF and armature reaction MMF separately. Two tests are performed on the alternator. One is open circuit test. Another one is zero power factor test. Open circuit test. This is the open circuit test for circuit diagram. Open circuit test switch is open. PM2 drive N as potential divided from 0 to rated value. Zero power factor test. Switch is closed. Purely inductive load. Purely inductive load as power factor cos 90 degree. This is the curve of Portier method. Same OCC and ZPF curve drawn. After that, RS voltage and armature leakage reactant IXL. IF is necessary to overcome demagnetizing armature reaction. And SQ is a IF required induced EMF balancing leakage reactance that find out to the open and short circuit values. American Standard Association methods. Load induced EMF calculated as an ZPF method corresponding EMF the additional field current. Due to saturation obtained OCC gap line IF3 added resultant IF1 IF2 for total field current E phase bound from OCC regulation is calculated. E phase is equal to V phase plus I phase R phase plus I phase X phase. Thank you.